Okay, let's practice this again. Okay, number 6. This is exactly the same with number 5. And as I told you in this video, I'm going to show you how we can solve this one, but I'm not going to show you the trajectory, okay? But like, I will show you how we can find the direction field in class, okay? Here we go. The process is same, okay? Find eigenvalue, then find eigenvector, then we can set up the fundamental set of solution, okay? That's it. Here we go. Eigenvalue. How can I find it? We're going to set determinant of a minus lambda I equals 0, okay? So which is determinant lambda equals 1, and lambda square is 2. Square is 2. 0. And its value is 2. Factoring, right? Lambda plus 1 and lambda minus 2 equals 0. Then I have like 2 eigenvalues. Let's say lambda 1 and lambda 2. Okay? Then now we have to find eigenvectors. Okay? So first of all, let's start from first eigenvalue, which is lambda 1. Okay? Then as I told you, what we're going to do is like this one. A minus 1 I v is equal to 0. Okay? Let me make the space here. Okay? Here we go. Plugging minus 1 into my lambda, which is a plus 1i, right? Then 2, 1, 4, 2, and let me write element wise. As I told you, you always have like this situation, okay? First row and second row is the same, okay? We can say 2v1 is equal plus v2 is equal to 0. Then I can say v2 is minus 2 v1. If I say like v1 is 1, v2 is 2. So my first eigenvector is going to become negative 2. That's it. Okay. Second one. Lambda 2 is 3, right? Do the same thing. Here we go. Then I will do a minus 3i equals 0, which is 1 minus 3, which is negative 2, 1, 4, 1 minus 3. And v1, v2 equal to 0 and 0, right? And again, they are same thing, okay? Minus 2 v1 plus v2 equals 0, then I can say v2 is 2v1. If I say v1 is 1, then your v2 is 2, right? So my second eigenvector is 1, 2. Perfect. We're done. Okay? This is the simplest case, okay? Now, we can write the solution matrix as C1 times e to the eigenvalue, which is minus 1 minus t, and my eigenvector. And C2 e to the 3t and 1, 2. Is okay? Then, okay, like, I will show you the trajectory in the class, but like before then, we can just like simply analyze about this situation, okay? So, well, if I set my t equals to infinity, then look at that. First term, C1 times e to the minus T1, 2, it goes to 0. But second one, can you see me? Second one is different, right? Second one goes to like, well, the 1, 2 means it is the line x2 equal to x2 is equal to 2x1, okay? So it is like, kind of like 45 degree. If I assume like an x-axis x-axis is x1 and y-axis is x2, then like it is like, the y equal 2x, I mean like slope 2 line, okay? And I will show you with the trajectory in class, okay? So like, before then, let me state like this way. Basically, when x goes to infinite, goes to infinite, comma infinite, but it is along the line y2 is equal to 2y1, okay? That's it.